Good afternoon, Mr. David and students. Today we will be discovering the world of 2D and 3D shapes. Our group members are me, Zhen Yu, Liang Yi Xi, Gan Yi Xin, and Lum Ee. Here is our table of contents. We have points, lines, and angles, parallel lines, perpendicular lines, and related angles, congruent figures, line symmetry, rotational symmetry, polygon and circles, and 3D shapes, which include plans and elevations.
Now I'm going to talk about points, lines, and angles. Points. Point is an exact location on a plane. It does not have any length, width, shape, or size. It only has a position. Lines. Lines is a straight path extending in both directions with no endpoints. Line segment, a part of a line that includes 2 points called endpoints and all the points between them. Ray, a part of a line with one endpoint that continues without end in one direction. Angles is a figure which is formed by two rays or lines that share the same endpoint. The point at which the two rays meet is called vertex, usually measured in degree or radians. Here are some examples of angles. First is acute angles, which the measurement is less than 90 degrees. The second is right angle, which is 90 degrees. The third is obtuse angle, which the measurement is less than 180 degrees. The fourth is straight angle, which is 180 degrees. The fifth is reflex angle, which the measurement is less than 360 degrees. And the last is complete angle, which is 360 degrees.
Now I will be talking about parallel lines, perpendicular lines, and related angles. So parallel lines are two lines in the same plane that are at equal distance from each other and never meet. They can be both horizontal and vertical. In shapes, parallel lines are represented with a pair of vertical lines between the names of the lines, using the sign which is shown in the picture beside. Perpendicular lines are formed when two lines meet each other at the right angle or 90 degrees. If two lines intersect each other at the right angle, then the lines are perpendicular to each other. A note that we must take is that perpendicular lines always intersect at 90 degrees, but not all intersecting lines are perpendicular. Here's an example of lines that intersect each other but are not perpendicular lines. Now I will be talking about related angles. Related angles is a pair of angles that are related to each other. For each pair of related angles, there is a particular name given to them. These angles are related to each other based on some specific conditions. For example, when a transversal cuts the parallel lines, then there are certain angles that are formed, such as corresponding angles, alternate interior angles, vertical angles, and etc. Thus, these angles are related to each other with respect to the condition of transversal and parallel lines. The examples of related angles are co-interior angles, which occur in between two parallel lines when they are intersected by a transversal. The two angles that occur on the same side of the transversal always add up to 180 degrees. You can spot co-interior angles by drawing a C shape. The two interior angles are only equal when they are both 90 degrees. Another example is the alternate angles. These angles occur on the opposite sides of the transversal line and have the same size. There are two different types of alternate angles, alternate interior angle and alternate exterior angle. You can often spot them with the Z shape. Next, we have corresponding angles. These angles are located on the same side of the transversal in corresponding positions. They are always formed in pairs and are congruent to each other, which means to have the same shape and size.
Congruent figures. What is congruent figures? Congruent figures are geometric shape. They are identical in both size and shape, allowing them to align perfectly without any need for rotation, flips, or distortions. Different types of geometric figures. Congruent line segments, congruent angles, congruent triangle, congruent rectangles, congruent circles, congruent polygons. Congruent line segments are usually identical by drawing the same amount of little thick lines in the middle of the segments perpendicular to the segments. There are photos under the information. Congruent angles. The angles that have equal measure are seen everywhere. For example, in equilateral triangles, isosceles triangles, or when a transverse intersects two parallel lines. In the both image, both the angles are equal in measurements, 16 degrees each. Congruent triangles, when pairs of their corresponding side and their corresponding angle are equal. They are of the same shape and size. Two triangles need to be of the same size and shape to be congruent. For example, point Q R E equal to X, Y, Z. Congruent rectangles have the same size and shape. It means that their corresponding sides are equal in length and their angles are also congruent. Congruent circles. Circles that are equal in terms of radius, diameter, and surface area.
Pair of circles. Congruent circles. What are congruent circles? Okay, before I get there, look at this. Say I have a circle with its radius as 5 centimeters. I have another circle with the same radius as 5 centimeters. Here, they're similar circles, but they don't share the same center, so they're congruent. That means congruent circles are circles that have the same radius but different centers. So these two circles here are congruent to each other because they have the same radius of 5 centimeters and different centers. Concentric circles. Concentric circles are two circles that have the same center but different radius. Same center, but they measure different radius? How is that possible? It's like a circle in a circle. Exactly, like this. Radius of the inner circle is smaller than the outer circle. These two are concentric circles because they have same centers but different radius. Intersecting circles. Okay, say I draw a circle, and then I draw another circle overlapping the first one. They don't have to share the same center, but they can have different radius. That means circles which intersect at one or two distinct points are intersecting circles. But how can two circles intersect at one point? I can only think of two intersecting points. How is that possible? I'm glad you asked that question. Here, how about this one? I draw a circle. I draw another circle touching only one point of the circle. Oh, a circle in a circle. Right. How about this one? Oh, wow. Never thought there are many ways to do this. Now tell me, what do you think these circles are? Concentric, congruent, or intersecting? These are all concentric circles because they have a common center. Exactly.
Congruent polygons. Polygons that is the same shape, has the same length of sides, and has the same interior angles of the polygons it is being compared to. For example, triangle, squares, pentagon, rectangle, hexagon.
Congruent polygons. Hi dear students, welcome back to my classroom. For today's lesson, you will learn how to visualize congruent polygons. Let's begin. Let's take a look at these two pairs of polygons. What can you observe? The first set of polygons are congruent polygons, while the second one are not congruent polygons. Now, by simply looking at these two sets, can you tell the difference between congruent and not congruent polygons? Let's find out. Congruent polygons are two or more polygons which corresponding sides and angles are congruent. We can say sides are congruent if they have the same length, while angles are congruent if they have the same measure. For example, we have here two triangles. Let us observe. We can see that these two triangles have the same measurement of angles, where two angles are 51 degrees and one angle is 78 degrees. Therefore, they have congruent angles. Also, we can say that their corresponding sides have the same length, where two sides are both 10 meters while the other one is 16 meters. Therefore, they have congruent sides. Since they have congruent sides and angles, it means they are congruent polygons. Now, congruent polygon necessarily must have the same shape and same size. Going back to our sets of polygons earlier, we can see that the first set have the same shape. Also, the tick marks indicate that the corresponding sides of the two polygons are congruent, and that the second polygon is just a rotated version of the first one. Therefore, they are congruent polygons. While the second set of polygons are not congruent, since they don't have the same shape and size, which means they don't have congruent size and angles. Let's have another example. Let's find out if this pair of triangles is congruent or not. First, let's take a look at their angles. Here we can see that they have the same measurement of angles. Therefore, they have congruent angles. Next, let's take a look at their corresponding sides. Here we can see that their corresponding sides don't have the same length or measure, which means they are not congruent. Now, even though these triangles have congruent angles, we can still say that they are not congruent polygons since their corresponding sides are not congruent. Last one. What do you think? Are they congruent polygons or not? The tick marks indicate that the corresponding sides of the two hexagons shown are congruent, and we can see that they have the same shape and size. The other one is just a rotated or flipped version. Therefore, they are congruent polygons.
So, what is line symmetry? Line symmetry is the line that divides a shape or an object into two equal and symmetrical parts. For example, the picture shown here, the square has 4 lines of symmetry, a rectangle has 2 lines of symmetry, and a rhombus has 2 lines of symmetry. Symmetric and asymmetric. So symmetric is a figure or shape that can be divided into 2 equal parts by a line, while asymmetric is the shapes and objects that are irregular and do not resemble each other when divided into 2 parts. Here are the examples of asymmetric and symmetric examples.
Next, we are going to talk about rotational symmetry. What is rotational symmetry? Rotational symmetry is when an object is rotated on its own axis. The shape of the object looks the same. Rotational symmetry can divide it into 3 parts. The first part is center rotation. Center rotation is for a figure or object that has rotational symmetry. The fixed point around which the rotation occurs is called the center of rotation. Next is angle of rotational symmetry. For a figure or object that has rotational symmetry, the angle of turning during rotation is called the angle of rotation. And the last one is order of rotational symmetry. The number of positions in which a figure can be rotated and still appears exactly as it did before the rotation, it is called the order of symmetry. Rotational symmetry examples. The center rotation is when the center of rotation of a windmill in the center of the windmill from which its blades originate. Angle of rotational symmetry. When a square is rotated by 90 degrees, it appears at the same time after rotation. So the angle of rotation for a square is 90 degrees. And the order of rotational symmetry. It is a star can be rotated 5 times along its tip and look at the same very time. Hence, its order of symmetry is 5. Here is the picture of example of rotational symmetry. A square has 4 rotational symmetry.
Polygon. A polygon is a simple closed figure in a plane that is formed by 3 or more sides. The sides meet only at the vertex. Here is an example of less frequently used polygon and frequently used type of polygon. Less frequently used polygon is dodecagon, nonagon, and heptagon. Frequently used type of polygons are triangle, hexagon, quadrilateral, octagon, heptagon, and decagon. Circle. A circle is a closed two-dimensional figure in which the set of all the points in the plane is equidistant from a given point called center. Part of a circle. A circle has different parts based on the position and their properties. The different parts of a circle are explained below in details. Annulus. The region bounded by two concentric circles. It is basically a ring-shaped object. See the figure below. Arch. Arch, a part of a curve, a part of the circumference of a circle. Sector, a region bounded by two radii and an arch. Segment, the section of a circle enclosed by a chord and an arch. Here is an example. Center, it is the midpoint of a circle. Chord, a line segment whose endpoint lie on the circle. Diameter, a line segment having both the endpoints on the circle and is the largest chord of the circle. Radius, a line segment connecting to the center of a circle to any point on the circle itself. Secant, a straight line cutting the circle at 2 points. It is also called an extended chord. Tangent, a coplanar straight line touching the circle at a singular point.
Last but not least, we're going to talk about 3D shapes, planes and elevations. Plans and elevations are 2D drawings of a 3D shape. A plan is a scale drawing showing a 3D shape when it is looked at from above. As you can see this picture, the plan that you see is from the top. So this triangle you can't see, you just can see the connected. Next one is an elevation is the view of a 3D shape when it is looked at from the side or from the front. Here is more examples of plan and elevation.
That's all for our presentation today. Thank you for listening.